it's low tech enough that I think anybody could build it. You don't have to weld to build this particular system. So what we've got here is a 55-gallon drum. It's got a hole that's been cut into it, and then this chimney's been fashioned onto it. These two allow us to create airspace between the chimney and the fire. It's just one of the stages. And then at the bottom of this barrel are a bunch of holes. Can everybody see that?
Mm-hmm. Yeah.
Drilled in. So what we want to have happen here is we're going to fill this, for example, with bamboo. That's our material of choice for this system. So we're going to fill, whoops, I put it in the wrong spot.
Yeah.
So we're going to fill this barrel with bamboo. We're going to cut the bamboo to kind of similarly sized pieces so that we end up with a pretty similar burn through all the pieces. All right? So we cut the bamboo into similarly sized pieces, we fill them up. Yep. We probably would even split these in half. Just to, again, we want a really complete burn if we can.
Agreed.
Fill this barrel up, and at the top we put kind of just some.
Just buy a dump truck and pick up 3 mulch from the
Probably
landfill.
something that's
No?
going to light very, very easily. Tinder, basically. So we're going to put that on top, and we're
Doesn't
going to light
hurt to
our fire.
experiment.
The heat of that fire is going to begin to pull air up through here. We're going to get a draft through the bottom of this barrel. And as that air comes up, pretty soon we're going to have this material burning. And as wood, as most kind of biomass burns, what happens is the heat is actually forcing the gases out of the material, and those gases are burning. And then, heat rises, and so it goes up into the air. And so what we're wanting to do is create this airspace here where all of our heat is burning those gases. We've got this chimney on there once we get it going good. And we're really drawing through heavily. And that's okay. And we're starting to see on the side of this barrel, the rust begins to disappear as that begins to burn down. And once we get down to about here, we know that we've kind of burned through most of the gases that are in that wood. And so we remove the sticks, we put sand around the edges, we take this off and just put a regular lid on top with a brick, and we basically try and stop any air from entering this system. Now we've got a ton of heat in this system, about 600-700 degrees Celsius inside this barrel. We still have a bunch of carbon, and we do have some other things that haven't burned off, but we're taking away the oxygen. And we've moved from oxidization, which is the corrosion of this material in the presence of heat and oxygen, to a process called pyrolysis, which is the corrosion of this material in the process of heat without oxygen. And what that does is it leaves us with charcoal rather than ash. If we leave oxygen in this system, we're going to burn this carbon into ash. If we take away the oxygen, this carbon stays intact, and what we're left with is charcoal. All right, or at least mostly charcoal. There's still going to be some trace things probably in it in an inefficient system like this. But the biomass we put in, about 25% of it by weight, we're going to get back out as charcoal. So why are we doing this in the first place? Well, in our sandy soils, two of our biggest problems to solve are the fact that nutrients readily leach through our soils, and our soils do not hold water well. All right? Well, wouldn't you know that charcoal, its structure, wants to hold on to nutrients, it wants to bind with them chemically and hold them in space, and secondly, it creates all kinds of orifices for water to hold into. So this fixes everything that's wrong with our soil.
And the atmosphere.
And as plants begin to pull carbon out of the atmosphere and trade carbon molecules for the nitrogen, the magnesium, the calcium molecule that's stored in this, they're taking that carbon and putting it here, and it's going to stay locked here for maybe 2,000 years before this finally erodes and goes away.
You just put it on?
So we want to amend this into our soil. We're going to first crush it into something that's about this size. All right? And because it's so lightweight, it would blow away if we just put it on top of the soil.
How are you crushing it?
Well, the way I've crushed it is by hand. I've created it's a metal plate welded to the bottom of a 3-inch pipe. It's about this tall, and there's about this much concrete in the bottom of the pipe. And we take turns until our arms fall off, and then somebody takes turns until their arms fall
What
off.
about an old garbage disposal? Does that work?
Ooh, it would eat the garbage disposal pretty. It worked for a while. Yeah.
You can roll over it too.
You can roll over it. You can run old lawnmower over it. It's really dusty, so you don't want to. A lot of the spinning systems create more dust than anybody would like,
That's where
and I wouldn't want to breathe this in.
Yes.
The other thing is, before we put here's the mistake I made. So, when we have this in its raw form, it is just a sponge wanting to absorb both water and bind with nutrients. Okay, it is an empty. This is a blank slate, an empty shell. But it is chemically designed, it is charged in such a way that it is going to attract the nutrients, the same kind of nutrients that our plants eat, it's going to attract them to itself. And it's going to do such a fabulous job that it's going to out-attract any root for that same nutrient. So if you were to put this in the ground and put a plant in the ground next to it, the plant would die because this would eat all the stuff the plant wants to eat, or it absorb all the stuff the plant wants to eat. All right? And so that's a mistake I made when the first time I used this. This is this is not a new technology, it's a rediscovered technology. And we're just starting to learn how to use it again. People knew how to use this stuff 1,000 years ago and we forgot. But 8 years ago when I started using this, there wasn't very much written material on it. And I hadn't read the part that said, you've got to charge this before you put it in the ground. And I put it in a palm orchard and subsequently killed 200 palm trees.
So that's where the whole like peeing on it or putting
exactly.
it on it or something.
So this needs to be charged before it's put into the environment where plants are growing. If you want to do that in a really, really fast way, you can fill a 5-gallon bucket with biochar. You could fill that bucket, top it off with urine, and probably in 24 or 48 hours you'd have something that isn't going to outcompete your plant, especially for nitrogen.